Third video of our calculus series. In this video, we're going to be discussing what continuity and differentiability both are and how they affect each other. So a continuous function is a function that does not have any abrupt changes in value, known as discontinuities. And we have seen some examples in the previous videos, but I'm going to draw one out right now to jog your memories. So say you have the following interval 2 to 8, and you have a simple line like this. So this function would be continuous in the interval 2 to 8. However, you can also have a graph on the same interval but the graph is discontinuous. And this specific graph is actually called a jump discontinuity, which was mentioned in one of the previous videos. So the general rule to use in order to know whether a function is continuous or not is the following. So this is the more formal notation. The limit of f of x as x approaches some real number a from the left-hand side equals the limit from the right-hand side, and it also equals the actual value. So this can just be simplified down to the limit of f of x as x goes to a, and it has to equal the actual value. Moving on to differentiability, the process of finding a derivative is actually called differentiation. A function is differentiable at x equals c and is differentiable on an open interval if it's differentiable at every point in the interval. So for example, this first graph right here, this would be differentiable because it is continuous. But this graph right here is not differentiable because it's not continuous. But an important note to keep in mind is that differentiability guarantees continuity, but continuity does not guarantee differentiability. So this is one specific case where it happens to be differentiable. But let me show you a case where it would not be differentiable. So say you had a graph in the same interval, and you had something like that. Remember that a derivative indicates there can be a tangent line at a specific x value. But in this case of a cusp, you can't really have a tangent line since there's no curve. So in this case, we know that it's continuous, but it's not differentiable. So remember that just because a graph is continuous, it does not indicate differentiability. It's only one of the factors. Now we're going to do a small proof to actually prove that differentiability guarantees continuity. So let me clear the canvas. So recall what we just did, where f of x is continuous at x equals c if the limit of f of x as x goes to c equals f of c. Now assume that f of x is differentiable at x equals c. Now consider the limit of f of x minus f of c as x goes to c. Now let's multiply the numerator and the denominator by x minus c, and you'll see why that'll help us see things clearer. So now we're going to split this expression into two separate limits by using a limit property, and we're going to find out that the result is actually 0. So you can split these up, where this is also limit as x goes to c, and this portion right here we can just bring down, and this portion right here we know is the limit definition. Actually, we learned it as this right here, but if you think about it, this right here is actually the same as this right here. So we know that this is just the derivative, so we can just put it in derivative notation, f prime of c. And we know that this is going to be 0 because, so for example, say the c is just 4, and we know that x is approaching 4, so x would be close to 4, and you're subtracting by 4, so it's going to be 0. So that limit is just 0. And you can bring down the f prime, and anything times 0 is just 0. So what does this really mean? We just proved that this right here is just equal to 0. So what does that imply? We know that we can just split that up, and then we can move one of them to the other side, and this would just be equal to f of c, and we can bring this down. So this right here proves that differentiability guarantees continuity, because the limit of f of x as x goes to c is equal to the actual value f of c. And that's it for this video. Hope you learned and enjoyed. Hope to see you in the next one. Please like, comment, and subscribe.